Electricity generation is the process of producing electrical energy from other forms of energy that are in abundance. Since electricity does not exist freely in nature, it is therefore produced by converting other natural forms of abundant energy from sources such as moving air, which is wind, flowing water, hot steam, human muscle. This is when you foot press a pedal or use your hand to rotate an axle. Then exploding gas. These are fuels that are put in an internal combustion engine, which are ignited to burst inside the engine cylinder, and many more others. All these sources of energy have got moving particles that push the blades of a turbine attached on a single axis, and to which tons of wires are wound within the fields of a magnet. By natural principle, when any conductor or a wire moves within the magnetic field, moving perpendicularly to the direction of the magnetic field, then the mechanical energy causing the wire to move is converted into electrical energy. This is the electricity we all know. If you connect your electric load such as a motor, heater, charger, etc., then electrical current will flow through it and make it work. In my case, I have used a bulb which will give off light for us to see. The amount of electrical energy generated is always directly proportional to the turbine speed. In other words, the amount of electrical voltage being generated increases with the increase in the speed of rotation of the turbine blades. Now, when you remove these energy sources from interacting with the turbine blades and also replace the load, which is the bulb in our case, you replace it with the battery, then the electrical current will flow from the battery into the wire windings that are located within the magnetic fields. The interaction of the electrical current flow into the wire perpendicularly to the magnetic field causes the wire to be pushed about the axle, which also rotates the blades connected to it. This forms what is known as a fan. The rotation speed is directly proportional to the electrical energy. In other words, the speed of the blades increases with increasing electrical voltage that is coming from the battery. Therefore, you will find that a generator and a motor are basically the same thing. The only difference is that if a generator axle is rotated, it produces electricity in its wire windings, whereas on the same device, if you allow electricity to enter into its wire windings, its axle rotates, turning out to be a motor. The purpose of this video is to see how we can generate electricity using a motor as our generator. Then the source of energy we are going to use is a human hand muscle. I started by getting a wooden platform with 4 legs and to which our entire generator setup is going to be fixed. I also got some 2 house fan gear sets which are going to increase the running speed of our generator from a low speed hand rotation. And lastly, I got a round plastic plate. This I cut from a jerry can, and some screws, bolts and nuts all together. The first step is to connect the 2 gear sets from a house fan together. This is done by connecting the output rotary shaft of the first gear set into the input rotary shaft of the second gear set and ensure that the 2 shafts are tightly fixed together. Then a pin is passed through both shafts in order to avoid them from sliding against each other when rotating. This will prevent some power loss at that point of contact when a rotation is being done. To see whether the 2 shafts are aligned perfectly, they are first placed on the wooden platform and then screwed with nails to tighten them within their alignment. and then make sure that they rotate properly without any kind of resistance felt in the hand. Then I got the round plastic plate which I fixed on the input shaft of the first gear set using a bolt and a spanner to tighten it properly. From there, I got another bolt and fixed it on the plastic plate at its extreme end and tightened it with a nut. To avoid the bolt from scratching up my hand, I used a metallic tubing which I entered around the bolt to rotate the entire setup and see how everything works. The motor I'm using as a generator has got wires wrapped on the stator and a magnet as a rotor. This means that it is the magnet which is going to rotate around the fixed wound wire. This produces the same effect as if it is the wire which is rotating around a stationed or fixed magnet. This means in our case that we are going to make the magnet rotate around the fixed wire. So I continue by getting the stator with many wire windings, and then I fix it on the wooden platform using nails and with the help of a screwdriver to tighten it firmly. I also get a metal tubing which I insert around the output shaft of the second gear set. The two are fixed together using a pin which is bent using a pair of pliers to avoid the pin from sliding out. Thereafter, I get the rotor which is housing the magnet. The rotor has got a shaft which shaft is passed through the stator of wire windings. This shaft is then fixed to the metal tubing and the two are joined together using a pin and a pair of pliers. This is how motion is transferred all the way from the rotating hand through the two gear sets which increase the rotating speed, and then to the magnet which is made to rotate around the fixed wires, ending up converting the kinetic rotational energy of the magnet into electrical energy. To see how fast the magnet is rotating around the wire, I get a white paper and stick it on the rotating magnet to see how fast a magnet makes a single revolution with increasing speeds of the hand rotation. The electrical energy produced from the generator wire increases with the increasing speed of the rotating magnet. At this point, I'm done making the generator setup, and next we are going to see how we can use this electrical energy power some appliances. But before we continue, let me first introduce to you an electrical socket that I redesigned to help you adjust the amount of power reaching your appliance. With a total load capacity of 9600 watts, you can use it to change the heating temperature of an electrical cooker, to adjust the brightness of the bulb, to change the speed of running appliances such as a blender, a fan, or workshop machines, and many more others based on your need. If you're interested in this socket, please contact me to make your order. The motor I have used is a 3-phase AC motor which has got 3 kinds of wire connections inside it. This motor, in order to rotate, it requires 3 voltages A, B, and C, which are separated from each other by some degree or time lag. If you use this motor as a generator, it will also generate 3 alternating voltages A, B, and C, which are separated by some degree or time lag. But since the load I'm using requires 1 voltage, which is direct and not alternating, Then I have to first make the 3 voltages being generated from the 3 wires into a single voltage as you're seeing. Then also convert it from being alternating into a stable DC voltage. Here I'm going to use a full wave bridge rectifier. This is a 3-phase full wave bridge rectifier which converts all the 3 voltages into one, and then a capacitor to remove much of the voltage variations, then an LED which lights blue to indicate that power has reached that point. Then finally the load. In this case I'm going to use a bulb and maybe a simple small DC fan etc. to use the electrical power that has been generated. After constructing the electrical circuit as described previously on the whiteboard, to convert the alternating voltage into direct voltage, I got some 3 wires to elongate the wiring from the generator to this constructed circuit. I also got a multimeter which I connected to this circuit to be used to measure the generated converted DC voltage so that I can see how much voltage our generator can produce at a certain speed of the hand. As you can see, when I increase the speed of my hand, the rotation of the motor also increases highly, which also increases the produced voltage being delivered as measured by the multimeter. So when I get an electric bulb and I connect it to this circuit to be powered by the produced electricity from our generator, and then I turn off the background light, when I start rotating the generator, notice that the bulb lights pretty well with some kind of a good brightness being observed. Also, when I turn on the background light, the brightness of the bulb is still noticeable and it persists as long as the generator is still being rotated to produce electricity for it to keep lighting. When I remove the bulb and replace it with a PC fan, which I connect to the circuit to be powered by the electricity produced from the generator, you see that the fan starts to rotate with its speed increasing with increase in the generator speed. And meanwhile, as you continue enjoying this video, you can like it or share it to your friends and even subscribe to my YouTube channel of Binge Inventions as a way of supporting me. Now, next we are going to see how we can use this generated electricity to charge a mobile gadget such as a phone. Sometimes the electrical voltage being produced from the generator may be far greater than what some loads may require. For example, you can see from our generator that if you turn it to run very fast, its output voltage raises even to beyond 20 volts. If you feed these 20 volts into a phone, the phone will get damaged because a phone is designed to use only 5 volts to charge. Because of this problem, there is a device called a regulator which inputs higher voltage and outputs a constant 5 volts, which is friendly to the phone to charge properly without damage. The input voltage from the generator is not constant and it varies basing on the speed of the generator. As long as the input voltage is greater than 5 volts, the output from the regulator will always be 5 volts. So, after inserting the regulator as previously explained on the whiteboard, I also connected the multimeter to indicate the voltage being output from the regulator. You can see that when I start rotating the generator, the output voltage does not exceed 4.9, which is approximately 5 volts, however much I increase the speed of rotation of the generator. So, when I get a mobile phone and attach it to our circuit using a USB port and then start rotating the generator, you'll find that the phone starts to charge immediately. Now, I connect a multimeter to indicate how much voltage is reaching the phone for charging, and when I start rotating the generator, you notice that the voltage does not exceed 5 volts. Of course it's 4.95, which you can approximate to 5 volts. However much I increase the speed of the generator, the output voltage reaching the phone remains the same and does not change that much. Well, that has been my video on how to generate electrical energy from a human hand muscle power. Thank you for watching. Binge Inventions wishes you well. See you in my next video. Bye bye.